Today's lecture is about electron configuration. We started our discussion about electron configuration in class, and tonight's lecture helps us to figure out exactly how to place electrons around the nucleus of an atom. Electron configuration, by definition, is the placement of electrons around the nucleus in energy levels as well as their sublevels. Principal quantum numbers are what we call the energy levels. They are designated with the letter N. We can have up to 7 principal quantum numbers for any given element. 1 through 7 here. The principal quantum number is the principal energy level. As the value increases, 1 through 7, the energy level also increases. Each energy level contains sublevels where the electrons are found. The number of sublevels is equal to the principal quantum number. What I mean by that is energy level 1, let's see here, level sublevels. Energy level 1 has 1 sublevel. Energy level 2 has 2 sublevels. Energy level 3 has 3. 4 has 4. But once you get past 4, we've maxed out. So 5, 6, and 7 also have 4 only. This slide is not intended for you to draw anything from. I just want to discuss this a little bit with you. There are 4 types of sublevels that we have that I just discussed on the last slide. The first sublevel is S. Oops. The second sublevel is P. The third is D. And the fourth is F. What I want you to take from this is that sublevel 1 has 1. Let me change my color here. Sublevel 1 has 1 orbital. The P sublevel has 3 orbitals. They look like dumbbells. The D, we're going to look at common only. The D has 5 possible orbitals in which we can find an electron. F has 7, and we'll only look at the general. You will never have to draw these orbitals. I'll explain to you what we do instead of drawing them. But what I want you to understand is that each orbital holds 2 electrons. So an S sublevel can hold 2 electrons. A P sublevel has 3 orbitals. They each hold 2 electrons. So a P sublevel can hold a maximum of 6 electrons, 2 in each. Again, I have a table on the next slide for this. The D sublevel has 5 different orbitals, each holding 2. That's 10 electrons maximum. The F sublevel has 7 orbitals with really crazy shapes here. 7 times 2 electrons in each is 14 electrons total. There's some pretty crazy shapes here. The other thing I want you to quick notice is how these shapes look when they're placed around the nucleus in an atom. And for each energy level, it keeps building outward from the nucleus. So you can imagine this gets pretty bulky, even though we're talking about a teeny tiny small space. For this slide, this is your note-taking slide. I want you to pause and copy everything you see down here. What's important for you to understand is that this slide tells you and recaps each sublevel, the number of orbitals, and the maximum electrons in each orbital. This slide also provides you with the 3 rules for electron configuration: the Pauli exclusion principle, the Aufbau principle, and Hund's rule. It is necessary that you learn all 3 rules and that you know how many orbitals are in each sublevel. Please copy this down now. Now, things can get a little complicated when it comes to energy levels. Of course you knew there was going to be a catch to all of this, right? Unfortunately, we need to be mindful of the fact that the energy levels overlap. So I'm going to make this picture bigger real quick. Oh, maybe not. I'm not sure why I can't get that over. Take a look here. I only show 5 energy levels in this diagram, but if you start taking a look, let's see here. The first energy level has an s orbital. The second energy level has an s and then a p. The third energy level has an s, p, and d because it has 3 different sublevels. But the fourth energy level right here, guys, its s is lower in energy than the 3D. If you take a look, there's a couple other places where when we get to the fifth energy level, its 5s comes before the 4D and the 4F. And the fifth energy level's P sublevel comes in before the 4F as well. Things get quite complicated. So what we've done is we have figured out a way to help you learn the order of the energy levels and their sublevels through this diagram. I want you to pause right now, and I want you to copy down all in this red box. This is what's going to help you understand the order in which we write electron configurations.